Hello, geometry students. We are leaving chapter 4 behind us and we are going into chapter 5. Chapter 5 is actually going to be a shorter chapter, and what it's going to be about is relationships within triangles. Specifically, what are some things that we can figure out about one specific triangle? So in this first section, we're going to be talking about something called midsegments. And what I'd like for you to be able to do is to use midsegments of triangles to solve problems by the end of this section of notes. So first we need to define what a midsegment is. A midsegment is a segment that connects the midpoints of two sides of a triangle. All right, a midsegment is a segment that connects the midpoints of two sides of a triangle. Now, I want to draw just a little image of that real fast just so you can see what I mean. So let's say that we have this triangle right here, and a midpoint is the very center of a line. So I would say this would be a midpoint and this would be a midpoint. So notice how this half and this half of this left segment is congruent, and this half of this right segment are congruent. Now, if I were to connect those across right here, that red line right there is the midsegment. Alrighty. Now, let's talk about two properties or facts about midsegments. The first is it is parallel to the third side of the triangle. Now, what do I mean by the third side? So if we go up here and look at this image again, notice how the left side and the right side are kind of touching this segment. So the third side would be whichever one is left over, whichever side is not touching the midsegment. So that means this line and this line are parallel. I'll highlight them just so you can see their relationship. So this line and that line are parallel to each other. Another relationship between them is the midsegment is half the length of the third side. So if we were to reference our image up here once again, if this bottom longer part were 10, then the top part would be 5. If this bottom part were 24, this one would be 12. You can also do it in reverse. So if this top one were 15, then the bottom one would be 30. So the midsegment is half of the lower one, or the lower one is double the midsegment. Alrighty. So now that we have those two properties, let's use them to solve some problems. It says, what are three pairs of parallel line segments in the image below? Okay, so first, we need to know that these guys are midsegments. So this guy is a midsegment. The reason I know that it is because it marks over here that this half is congruent to this half, and this half is congruent to that one. That's letting us know, oh, hey, this point G and this point F are smack dab in the middle. If they're smack dab in the middle, then they're midpoints, which means that that's going to be a midsegment. So I can now say that segment GF is parallel to segment BD. So I'm going to highlight that in pink for you as well, just so you can see what it corresponds with. So those two guys line up with each other. But we have some more midsegments. I know that EF is parallel to BC. Now remember, parallel means to go in the same direction and to never intersect. Parallel does not mean congruent. Parallel means they are going in the same direction. So our next pair is going to be EF is parallel to BC. And our final pair, I need to get a different highlighter. Here we go. GE is going to be parallel to CD. Parallel to CD. Wonderful. Now, there is one more little attribute that I want you to think of. Notice the pink lines real fast. This segment from B to E, and this segment from E to D, and this segment from G to F are all congruent to each other. Now let's look at the greens. This half of the green, and this half of the green, and this green are all congruent to each other. Finally, for the yellow as well, this half of the yellow, this half of the yellow, and this yellow down here are all congruent to each other, which means when you have 3 midsegments, it forms 4 congruent triangles. So, this triangle right here is congruent to this triangle right here, which is congruent to this one, which is congruent to this one. All 4 of those are exactly the same size, which means all of their corresponding angles and all of their corresponding sides are also going to be congruent. All right. So we're going to use that in our next example here in just a minute. First, it wants us to find each measure. So it wants us to find the measure of BD. All right, well, BD is a line segment, and that's from here to here. BD's length corresponds, or correlates, I should say, with AE's length, and I know that AE is 17. Well, remember from up here in my properties, the midsegment is half the length of the third side. So if the third side is 17, to find BD, I need to take half of it. So what I'm going to do, I'm going to take 17 divided by 2. That's going to get me 8.5, and that's going to equal BD. For my next problem, I want to find the measure of angle CBD. Okay, so let's identify that in the image. From C to B to D, B is the vertex of the angle, which means it's going to be this guy right here. How on earth am I going to figure out that angle? Well, what I want you to remember is that these triangles are congruent to each other. So this triangle down here in the middle is going to be congruent to this triangle at the top. Now it's just up to us to figure out the corresponding parts to it, so to say. So I'm going to put 1 mark here, 3 marks here, and 2 marks there, just so I can see. So notice 1, 2, and 3, and then 1, 2, and 3. So this mark and this angle, which is an angle I was given in that lower triangle, sorry, I didn't mention that, but yeah. This angle right here is this 26 degrees. Notice how this angle is between these two sides, and it has 3 marks right here and 1 mark right here. So I need my angle to have 3 marks on one side and 1 mark on the other. Well, this guy up here, angle CBD, has 3 marks on one side and 1 mark on the other, which means B, or this angle, and this angle are in corresponding positions. Because they're in corresponding positions, that means that they are the same size because these triangles are congruent. So I now know that the measure of angle CBD is 26 degrees. That's my answer to that one. All right, we only have 1 more example, and then we are, no, I apologize. We have 2 more examples on the back of this piece of paper. All right, so in example 3, it says, in an A-frame support, the distance PQ is 46 feet. What is the length of the support ST if S and T are the midpoints of the sides? This part right here is telling us, oh, ST is a mid-segment. It's spelling it out for you. So this guy is a mid-segment. And it's also telling us that the distance from P to Q is 46 feet. So looking at my front again, the mid-segment is half the length of the third side. All right, so in this example, the third side is 46 feet. I need to take half of that to figure out what ST is. So I'm going to take 46 divided by 2, and that's going to get me 23 feet is equal to ST. And there's our solution. All right, now we're to the final example. The final example is a little bit lengthier, and I'm going to try to break it down for you as best as I can. So it says, the vertices of triangle XYZ are -1, 8, 9, 2, and 3, -4. M and N are the midpoints of XZ and YZ. Show that MN is parallel to XY and MN is equal to half of XY. That is a lot. That's a whole lot of information. So for step 1, let's graph it. We need to graph what we know. So that's what I'm going to do first. I'm going to graph triangle XYZ. X is at -1, 8, so back 1, up 8. There's X. Y is at 9, 2, so over 9, up 2. And Z is at 3, -4. So there's Z. Now, I'm going to connect these. I'm going to use a pencil in case if I mess up, because I'm not the best at drawing straight lines, apparently. Okay? Just a second so I can have this at a good angle. Just connecting this as best as I can. All right, there we go. Get that centered for you guys again. All right, so I have my triangle drawn. Step 2, it says M and N are the midpoints of XZ and YZ. 2, it does not tell us specific coordinates, so I need to calculate what M and N are. So for step 2, I'm going to calculate the midpoints. Problem is, how do I do that? There is a midpoint formula. We've talked about it. I believe it was in chapter 1, maybe chapter 2. I can't remember anymore. But we have discussed this, but I'm going to tell it to you again. The formula for a midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. Basically, add up your coordinates and divide them by 2. So for xz, I need to add up these two coordinates and divide them by 2 to figure out what the middle is. So I'm going to label this one x1, y1. This one is x2, y2. Let's plug in our numbers. So I have -1 plus 3 over 2. And then 8 plus -4 over 2. That's going to be 2 over 2 and 4 over 2, which equals 1, 2. So I now know from this, I just found the midpoint of XZ. So I'm going to graph it. It is over 1 up 2, so right here, and that's going to be point M. It's point M for us. I now need to figure out point N. Point N is going to be the middle of YZ. Okay, so I'm just going to temporarily ignore these. I'm going to label this one X1, Y1 now. I want to figure out the midpoint between Y and Z. So I'm going to use this formula once again. I'll just draw a little squiggle so we don't get my work mixed up. So I'm going to take X plus X or 9 plus 2 over 2, comma, and then 2 plus negative 4 over 2. That's going to be, 9 plus 3, my bad. That's going to be 12 over 2, comma, negative 2 over 2, which is equal to 6, negative 1. So this is now my new midpoint. So I've got a little bit of information starting to collect. These are my midpoints. That's what I calculated in this step. That's all I've been doing so far. So let's graph this. It's over 6 down 1, which is right here, and that is point N. Okay. So that was step 2. Step 3, it says show that MN is parallel to XY and that MN is equal to a half of XY. Alrighty, so I'm going to connect M and N real fast. And I want to show that this line segment from M to N is parallel from X to Y. Well, what I need you to recall for step 3, recall parallel lines have equal slopes. We talked about that, I believe, in the last chapter. Maybe it was 2 chapters ago. Parallel lines have equal slopes. So if I can figure out the slopes of these 2 lines, then I can determine if they're equal or not. Because I have a graph, I can easily count. Remember, slope is equal to rise over run. So I'm going to calculate the slope of MN. So the M, or the slope of MN, is going to equal, well, how far left and right do I have to go to get from M to N? So I go down 3, 1, 2, 3, over 1, 2, 3, 4, 5. So MN has a slope of negative 3/5. Let's find the slope of XY. How far does it take me to get from X to Y? So I go down 1, 2, 3, 4, 5, 6, down 6, over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this has a slope of negative 6 over 10, but this does reduce by a factor of 2, so that's going to get me negative 3 over 5. Notice how the slopes are the same. All right, because the slopes are the same, the segments are parallel. So I'm going to write that out. Because the slopes are equal, the lines are parallel. Okay, so we did that part. We have one more step. We also need to show that MN is equal to half of XY. Well, the issue is, to figure out if something is the half of something else, we have to calculate its length. How on earth are we going to calculate its length? We're going to have to use the distance formula. So the distance formula is going to be D is equal to x2 minus x1 squared plus y2 minus y1 squared. So what we can do, we can figure out the distance between x and y, and then we can figure out the distance between m and n. And if mn is half of xy, then we are done and we have shown what we want to show. So let's substitute in our values. Let's first find the distance from x to y. So my coordinates, once again, are -1, 8, and this one is, whoops, I bumped that, sorry. And then this one is 9, 2. So let's plug those in. So distance is going to equal the square root of 9 minus -1 squared plus 2 minus 8 squared. This becomes 100 plus 2 is -6, 36. Square root of 136 is about, actually, let's leave it just square root 136. And let me double check my work. So we have 9 minus -1, which is going to be plus 1, which is 10 squared. Good. And we have 2 minus 8, which is -6. -6 squared is 36. So we got the square root of 136. Cool. Now let's do from n to m. So that distance is going to equal the square root of, I'll write in my coordinates again. This is 6, -1. And this is 1, 2. So that's going to be 6 minus 1 squared plus -1 minus 2 squared, which that gets me 25 plus 9, which is going to equal the square root of 34. The square root of 34 is about 5.8, and the square root of 136 is about 11.7. If we take 5.8 and double it, we're going to get around 11.7. Oh, sorry, you guys. I didn't show you that to you. My apologies. So I just did the distance formula here, and then I rounded my answers. I can see now that 11.7 is approximately double 5.8, and because I was rounding, that makes sense, so that's good. I have now shown that MN is half of XY. I apologize about that last part, but that is our last example. If you have questions, bring them to me tomorrow in class, and have a good night. Bye.